Welcome to this presentation. The topic today is SURDS, and the question we have here is on simplification of SURDS. This is part 1. Part 2 will be a continuation of this work. So we have a question. Simplify as far as possible, leaving your answer in SURD form where possible. Part A, root 63 plus root 72 over root 32 plus root 28. Part B, 1 over root 5 minus 2 minus 1 over root 5. And for part B, we are to leave our answer in the form A plus B root C. Now let's begin with part A. Now here are the components: root 63, root 32, root 72, and root 28 are not yet expressed in their simplest forms, and therefore the first thing is to simplify them. So we are going to begin with root 63. Root 63 can be factorized as root 9 by 7, and this can further be expressed as root 9 times root 7. Root 9 is 3, and therefore 3 by root 7 is 3 root 7. Let me explain a bit how I was able to get 9 by 7. Considering the factors of 63, beginning with 1, 1 by 63 is 63. The next factor after 1 is 3. 3 by 21 is 63. And after 3, the next factor is 7. 7 by 9 is 63. Now of these pairs, we identify a pair with a square number. In some cases, you may have of the factors more than one square number, and for such cases, just pick a pair with the largest square number. For our case, we only have one square number, and that appears in the pair 7 by 9. And that is how I was able to arrive at 7 by 9 and then use it here. Now we'll continue in the same fashion for root 72, root 32, and root 28. Beginning with root 72. Root 72 is 6 root 2. That is applying the same procedure. For root 32, we have 4 root 2. And then finally for root 28, we have 2 root 7. Now with these already simplified, we can now rewrite this. On the numerator, we have root 63. Root 63 will be replaced by 3 root 7. So we have 3 root 7 right here. And in place of root 72, we will have 6 root 2. That is here. And then for root 32, we are going to replace it with 4 root 2. So we have 4 root 2 right here. And finally, root 28, we have to replace by 2 root 7. And therefore, we have 2 root 7 here. Now for this part, the next thing is to simplify it further. And we can note that on the denominator, we have SURDS, and therefore we will rationalize the denominator by multiplying it by its conjugate. So the conjugate of 4 root 2 plus 2 root 7 is 4 root 2 minus 2 root 7. You'll notice that in the first bracket we have 4 root 2 and 2 root 7, just the same way we have in the second bracket 4 root 2 and 2 root 7. The only difference is the first bracket we are adding, and in the second bracket we are subtracting. So this forms the conjugate of 4 root 2 plus 2 root 7. Now because we've multiplied the denominator by the factor here, 4 root 2 minus 2 root 7, the numerator must also be multiplied by the same factor. And therefore, the next step, we are going to expand the numerator. This is what we have on the numerator. Now, in order to expand, that is to remove the brackets, we'll begin by multiplying 3 root 7 by every term in the second bracket, and repeat the same procedure for 6 root 2. So 3 root 7 multiplies 4 root 2, and that gives us 12 root 14. We'll have 3 multiplying 4 to give us 12, and then root 7 multiplying root 2 to give us root 14. Next, we multiply again 3 root 7 by negative 2 root 7, and that gives us negative 42. 3 multiplies negative 2 to give us negative 6, and then root 7 multiplies root 7 to give us 7. 7 by negative 6, that is negative 42. Continuing the same way with 6 root 2, we'll have 6 root 2 multiplying 4 root 2, so that we have positive 48. That is 6 by 4 gives us 24. Root 2 by root 2 gives us 2, and therefore 24 by 2, that gives us 48. Again, we multiply 6 root 2 by negative 2 root 7, and that should give us negative 12 root 14. 6 by negative 2, that gives us negative 12, and then root 2 by root 7, that gives us root 14, and therefore we have negative 12 root 14. Now working out the right hand side, collecting the like terms, we'll have 12 root 14 minus 12 root 14, and that is 0, and therefore 48 minus 42, that gives us 6. So that is the result for the numerator. For the denominator, first we recall that if you are given an expression a plus b into a minus b, where here a and b repeats in the next bracket, a and b, the only difference is addition and subtraction in the two brackets, then the result should be a difference of two squares, that is a squared minus b squared. Now I want us to relate this to what we have on the denominator here. 4 root 2 and 2 root 7 appears in the second bracket the same way. The only difference is addition in the first bracket and subtraction in the second bracket, and that means we have a difference of two squares. So the point here is to look for a way to square root 2 and also to square root 7 so that the surd disappears from the denominator, and that will be achieved by applying a difference of two squares. Now applying that to the denominator, this is the denominator. We have 4 root 2 plus 2 root 7 times 4 root 2 minus 2 root 7. So this is a difference of two squares, and therefore we're going to have 4 root 2 squared. Remember, 4 root 2 corresponds to A and 2 root 7 corresponds to B. And therefore we are going to have A squared, that is 4 root 2 squared, minus B squared, which is 2 root 7 squared. Next, 4 squared gives us 16, root 2 squared gives us 2, and then 2 squared is 4, and then root 7 squared is 7. 16 by 2, that is 32, and 4 by 7, that is 28, and therefore we'll have 32 minus 28, which gives us 4. Now 4 is the result for the denominator. Now taking the numerator dividing by the denominator, that is 6 over 4, we are going to have finally the answer as 1.5 or 3 over 2, or better still 1 and 1 over 2. And that is part A. For part B, we have 1 over root 5 minus 2 minus 1 over root 5. We are going to do this in parts. Let's begin with this first part here, 1 over root 5 minus 2, and then later on look at 1 over root 5. For the first part, 1 over root 5 minus 2 can be simplified by rationalizing the denominator. So we multiply the denominator by its conjugate, and the conjugate is root 5 plus 2. Remember, the only difference here is addition. Here we have subtraction and here addition. And because we have multiplied the denominator by this factor, the same factor should multiply the numerator. Well, work out the numerator. We are going to have root 5 minus 2. That is 1 times root 5 minus 2. And then on the denominator, we are going to apply a difference of 2 squares, just as we had seen earlier on. And that is root 5 squared minus 2 squared. And root 5 squared is 5, and then 2 squared is 4, and therefore 5 minus 4 is 1. So the numerator is root 5 minus 2, and denominator is 1. And therefore, rewriting this in its simplified form, we are going to have the numerator, we have root 5 minus 2 here, and then denominator is 1, so we have that over 1. And this simplifies further to root 5 minus 2. Moving to the second part, we are going to have 1 over root 5. Again, we rationalize the denominator by multiplying root 5 by root 5. The idea is just to ensure that the root sign disappears, and therefore root 5 by root 5 will be 5. And because we've multiplied the denominator by root 5, the numerator has to be multiplied by the same factor, that is root 5. Finally, that gives us root 5 over 5. Now, because we have the first part and the second part simplified, we are now going to subtract them, just as we have here. So the first part we have root 5 minus 2, and the second part we have root 5 over 5. Collecting the like terms, root 5 minus root 5 over 5 for the first part, and then finally we subtract 2. Root 5 minus root 5 over 5 should give us 4 root 5 over 5, which is also 4 over 5 root 5. And then finally we subtract 2, and this can also be expressed as negative 2 plus 4 over 5 root 5. And I've expressed it in this form because the question required us to express it in the form a plus b root c. As you can see, negative 2 corresponds to a, and therefore a is negative 2. 4 over 5 corresponds to b, and therefore b is 4 over 5. And finally, we have here 5 corresponds to c, and therefore c is 5. And that is how we go about these questions. I want to thank you for your patience. Thank you for watching. Hope to see you in the next video. Bye.